This video demonstrates how to use MICAS X, the Multi-Instrument Control and Acquisition System extended from Original Code Consulting. In this demonstration, we are using a ramp demo configuration file with the Student Edition of MICAS X. Installing the Student Edition is simple. Find instructions on the USB key that comes with MICAS X SE. Following those instructions, copy both the MICAS directory and the OCC directory to your C root directory. Instructions for installing other versions of MICAS are contained in the software documentation and on our website. The Student Edition is normally deployed as LabVIEW source code, so you need to already have installed LabVIEW 2015 before running MICAS X. To start MICAS, open the C MICAS X directory and double-click on the MICAS X LabVIEW project file. Then double-click on the micasx.vi to open the program. Click on the Run arrow to run it. When the program starts, it switches automatically to the Document Display tab. This display contains instructions for using this demo configuration, similar to what is in this video. You can come back and review this document later. Let's start with a quick overview of the main MICAS window. At the top is the menu bar. You can explore the features there later. Between the menu bar and the main tab structure is a space where various controls and indicators can be configured to be displayed. For this demo, the two indicators show the values of the ramp value voltage and the response in milliamps data channels. The alarm indicator and time and date are on the right of this area. These controls and indicators are always visible regardless of which tab is being displayed. The Control tab is the default user interface for MICAS. Many simple configurations can use this tab as the main user interface, but many other display and control options are available as well, including custom displays optimized for specific experiments. On the Control tab, you can configure any number of controllers, which is what output channels are called in MICAS, switches, sequences, and triggers. In this example, two controllers are shown, and their values can be adjusted directly by the operator. We'll revisit switches, sequence, and triggers. A list of all the data channels is shown on the right, and the bottom contains a time series graph for any two of the data channels. This configuration simulates a simple experiment in which the computer steps an excitation voltage, the ramp value voltage channel, over several minutes while measuring the system response, the response in milliamps channel. These channels are virtual channels that only exist in MICAS. That is to say, they are not connected to any real hardware, so this configuration can be run by anyone, regardless of what hardware they have available. To start the experiment, press the sequence button marked Press to Run Ramp Test. Within a few seconds, you will see the graph near the bottom being updated with the ramp value in white and the response in red. When the ramp value exceeds 35 volts, the sequence being run is programmed to alert the operator and wait for the HV interlock to be switched on before proceeding. When the dialog appears, acknowledge notification, then press the high voltage interlock switch to allow the sequence to continue. For this simulated system, a response level greater than 1 milliamp is deemed to be dangerous. When this level is exceeded, a trigger executes and starts a safety sequence. That sequence will notify the operator with a dialog, sound an alarm, turn the experiment sequence off, and set the ramp value back to 0. You can now explore the menu items in MICAS. Under the Program menu are items for opening the support folder and the data folder. Here you can see that the data for the current experiment has been saved in several files. These files are explained in the user manual, which you can access from the Help menu. The instructions in the document display also discuss the other menu items available. The Sequence Display tab is used to view all the sequences that are defined in the current configuration. They can be run and stopped from here if needed, though most often this display is used for debugging. The Utilities menu lets you access numerous additional programs that work with MICAS. Refer to the document display and the user manual for information on these utilities. For now, we'll open the configuration editor. MICAS is highly configurable and can easily be adapted to changing experiment needs. Multiple configuration files can be created to deal with different experiments. The configuration editor can be a bit daunting at first, but you can soon learn your way around. Review the documentation display instructions for more information. For now, we'll click on the Drivers component, then select the manual driver. Here, we can configure the virtual channels being used by this experiment, change their names, add or delete channels, and change their initial values. Other drivers can be edited to change other channels, and many other features of MICAS can be edited as well. Thank you for your attention.